Hello friends, today we are going to see about another machine learning algorithm, that was decision tree. Decision tree. This decision tree algorithm, it is a supervised algorithm. And this algorithm can be used for both classification and regression. And this this decision tree algorithm, its work on, it can be having a two type. It have a two type. One is ID3 and CART. These both are the types of decision tree, but the both having a little bit having a difference. Let's see what is that. In decision tree, it will use a tree based structure to classify or predict the output or outcome. Like we have a root node, and there is a sub node, and there is another sub node for this sub node. Like this algorithm form a tree like structure, and it will compute the output. But whenever is computing in CART, there is a root node, and the sub node will be have just two. It will have near two sub node only. But in ID3, a root node will have, but the sub node can be more than two, can be a more than two or two. This is the difference between CART and ID3. The CART have just two child, but a root node will have just call it as parent. The parent will have just two child. But in ID3, ID3 for a parent, it can have more than one or more than two nodes. It can be having a more than two nodes. This is the major difference between ID3 type decision tree and CART decision tree. In scikit-learn, we know about scikit-learn. This was the library which was used in Python to build ML model. In the scikit-learn, it uses CART based decision tree algorithm to make decision tree ML model. Let's see the concept behind the decision tree. In decision tree, there is two major mathematical concept that is the backbone of this algorithm. One is entropy and Gini impurity. And second one is information gain. The entropy and Gini impurity this both algorithm is used for check whether the node having a purity split. Purity split means whether the node is pure node or an impure node. We can see what is pure and impure in further when we are going in this lecture. Next, what is information gain? And this information gain is used to select a feature. It uses to select feature to select for. It will define features to select for DT construction. Let's take there is a node and there is let's take there is a data set. There is a data set that having feature like F1, F2 and F3 and a output, and the data set which having 3 features and 1 output. We start making 3 like structure by using F1 and it will have F2 and F3. Okay. It can have C1, C2, or we can start with F2. Like this, you can have F2 or F3, and when we start with F2, it will have F2, F1 and F3. Like this, we can start our decision tree, but we do not know which was the best option. Let's start with F1, or otherwise we can start with F2. Which one is best? To find a best feature to start with, we use information gain. To select a feature to start a to split with, we use information gain. And what is meant by purity split? For example, let's see with another example. Let's take a data set. This is the data set. Let's take Outlook as a root node, and Outlook having different categories like sunny, overcast and rain. Totally the Outlook have totally 1 2 3 4 5 6 7 8 9 9s and 1 2 3 4 5 nodes. And after splitting, here Sunny which having, let's see, Sunny having 1 2 no, 3 no, 1 s and 2 s. Totally Sunny having 2 s and 3 no's. This is impure split. And let's compete for overcast. For overcast, totally 1s, 2s, 3s and 4s. Totally 4s are there, and no's, I think there is no no's are there, 0 no's. This is pure node. What is meant by pure node? Pure node having value for having it will having a outcome for one value. For overcast there was there is only 4s and there is no 0s, so that this node is pure node, and this node is called leaf node. And but this Sunny having 2s and 3 no's, the both s and no having a value, so that this is impure split. Okay, or it can be called as impure node. And the rain is also having 3s and 2 no's. So to check whether the node is impure or in a pure form, we can use entropy or we can use Gini index. By using any one of this method, we can compute whether the node is pure or impure. We can check whether the node is pure or impure. Okay. Do not forget to note this. This is an important question which will ask in interview. How to check the node is pure or impure, pure or not. We can use entropy or Gini. It can be called as Gini index or Gini impurity. We can call this method as Gini index or Gini impurity. And what feature need to select for split? How can we will define? For this question, we can use information gain. By using information gain, we can select which was the best feature to start a split. Okay, let's see mathematical concept behind this both method. let's see about what is entropy. The formula for entropy is H of S equal to minus P plus log 2 P minus P minus and log 2 and P minus. This formula is for binary classification. For a binary classification, we have yes or no, or it can be represented as 1 or 0. We can consider yes as P positive and no as P negative. Okay, this P plus represent probability of S, and this P minus will represent probability of no. Okay, let's see how can we implement this formula in model building. For example, we have a feature F1. We need to split this feature having totally 6 S and 3 no's, and we will split if S okay, this feature is split into 2 parts. That means if C1 and there is C2, if it is S, we go to C1. If it is no, we go to C2. When this feature is S, we go to C1. If this feature is no, we go to C2. And this having a, and this node having a 3S and 3 no's, and this having 3S and 0 no's. By seeing this, we know that this is impure node. Impure split. This is impure split, and this one is pure split. Because the C2 having exactly 3S and there is 0 no, or whenever the C2 having 0S or and 3 no's, means this node or this category also come under pure node, pure split. We can call this condition as pure split, because there is no S but having a more than 0 no's, so that this form also called as pure split. Okay, let's compute H of S for this 3 H of S. Let's see H of S for C1. So we put minus. Let's put this data in this formula, and P positive means how many probability of positive. There are totally 6 conditions. Totally yes and no, there are 6 conditions. So denominator we will have 6 and there are 3S. We compute probability of S. So this is the probability of S, and log of 2 and probability, sorry, here it will come probability plus, and here will come probability plus. Probability plus is 3/6. and minus the if you want to compute probability of no, probability of P minus is probability of no. The probability of no is 3 by 6 and log 2, and here also probability of no. After computing this, we will get 1. The maximum value of entropy is 1. That means, so here by whenever we compute entropy, it will range between 0 to 1. It will range between 0 to 1. Here we are getting 1 as an output. Whenever we getting higher value, that means it is a 100% impure split. Here we are getting 1, so that this is 100% impure split. Let's compute entropy for this C2. Okay, for C2, just apply the same formula. Minus probability of positive is for C2 is 3 by 3 log 2 and 3 by 3, and then minus here there is 0 no's are there, so that 0 by 3 log 2 0 by 3, this whole value will having a 0 and you will get minus 1 here and log 2 of 1. So this will get value as 0. For we can see this, for an impure data we will get more than 0. Here we get more than 0 and less than 1. That means the HC1 is impure data. We will getting output as 1 and the result as 1. For C2 we get 0. That means this is pure split. So we cannot split, it is an pure split. So we do not want to split it further. Whenever we getting a entropy as 0 for an node or a feature, then we can stop that node as it is. We can split it further. By applying entropy, we can compute whether we need to split the node or data into further or not. Okay, let's see. Okay, we can see Jenny impurity and information gain in next video. Thank you.